I'm the technical lead for everything we are doing around OpenWhisk, and I have Andreas here with me, who is the offering manager for OpenWhisk, covering the business side. What we want to do over the next 35 minutes roughly is want to give you an overview of what's new in OpenWhisk, both from a technical perspective and also from a business perspective in terms of what customers are doing, how they're using it, drilling a bit deeper beyond what Jason said this morning. So just very briefly, OpenWhisk, two semantics of that. There is an Apache project called OpenWhisk that is the code foundation for what we have out there as a managed service. For the managed service is in Bluemix. So if you want to try it out, you don't want to install the code by yourself and just use the fast platform OpenWhisk as a user, you go to bluemix.net OpenWhisk. So what we want to do now is, by means of some customer scenarios or customer scenarios categories, explain what we're doing in terms of new technical functionality, what we are offering there. You've seen those scenarios over the course of the conference probably already a few times. Serverless API is very prominent and mass market scenario. Data processing, both data at rest and data in motion. Cognitive scenarios where you do some interesting things, AI kind of things, on top of the data, IoT, and mobile backends as well. So drilling into the first one, APIs, what are we doing there? As you've heard this morning, so far we had an experimental version of the API gateway in OpenWhisk available over the last month, got great amount of feedback from the community. And now we are making it generally available. The interesting thing is we are not charging on top of OpenWhisk for that. It's entirely free. You don't get charged. There is no fractured pricing. You just go there, you use the API gateway or not. You don't get charged any premium for that. And the benefit that it allows you to do is you define your API structure in the way you like to. You map it to OpenWhisk functions, and there you go. So what does the API gateway deliver in terms of functionality? You saw it a bit in the demo that Jason gave this morning. Various security-related functions, so you get API key support, API secret support, OAuth support. You can define rate limiting, so if you want to make sure that your API doesn't get called more than 10 times a second for whatever reason, maybe because you have backend systems that shouldn't get overloaded, or you want to limit the quality that you're delivering to a certain user, you can do that. You can map the actions to API endpoints. You can do that all with CLI commands or on the UI. In the backend, that's all handled via the API doc or Swagger. So if you want to, you can also go in there and directly manipulate the Swagger documentation and therefore have more fine-granular control. You get analytics out of the box in terms of how many API calls are being made, what are the error rates, what are response times that you're getting. You can test it directly within the UI, so whatever you defined there, you can test it within the browser. You get pre-canned curl commands that you can just copy into the clipboard, put on the CLI. So it's a pretty rich piece of functionality, which is, like I said, available for no additional cost. We are doing that just to make the pricing model as simple as possible and don't add hidden costs by having a fractured pricing model. So how does that look like as an example? So in the first step, you can see here a very primitive, probably one of the most primitive actions or functions that you can write for OpenWhisk. It's written in Node.js, and what it is doing here, it is returning a JSON payload. So it gets two parameters, a name and a place, and that is embedded into the response that is being returned. Note here, this is plain JSON, nothing else around that. We'll come back to that in a few slides from now. So once you save that code into a file, let's say you call it hello.js, you use the OpenWhisk CLI, you create a new action or function, you call it hello, and you specify the file that has the code in it. And then there is a simple command you need to issue for creating an API endpoint out of it. It might be /hello, and you want to make it accessible via GET. and you specify the action name that you just used in the second step, and that's all you need to do. You get as a return for that command the URL where that API endpoint can be called now. You can insert it into the browser and notice in the URL bar on the right-hand side there are two parameters in the query string, name and place, which are the ones that you can see in the first step where the code is. And those two parameters get passed on to the OpenWhisk action. It inserts the parameters into the JSON payload and returns it. So what if you don't want to handle just raw JSON, but have more control over the HTTP traffic going in and out of the action? The default programming model in OpenWhisk is you deal with raw JSON because it's important for compositional purposes. There are many use cases, as it was pointed out throughout the conference, that are not oriented towards web scenarios. So the native programming model is JSON, but we want to give people full control over what is going in and out HTTP-wise for the action. So how does that look like? Oh, let me just go back here. At the bottom here, we just created a simple action. If you want to make that a so-called web action that gives us the full control over the HTTP traffic, we just update it with a -- web true parameter, and that's all we need to do. From then on, the code or the JSON that gets returned from the action is interpreted in a special way by OpenWhisk. And we see that in a few examples here. The first example is an OpenWhisk action for sending a redirect. And you can see here there is a special element in the JSON that is being returned called headers. That's a convention that we are following whenever an action is defined as a web action, and it returns something that has a headers element in it. That headers element, or the content of that headers element, will be used to define the HTTP headers of what is getting returned. Same is true for the status code element. Here it's a 302, which means there is a redirect. Think back to the previous example. If we wouldn't have had the web true parameter specified here, if this wouldn't be defined as a web action, we would just be returning the JSON with headers and status in it, and it wouldn't be interpreted by the OpenWhisk engine. But given we have it specified, it does. Second example, for example, for setting a cookie, you can see again a headers element here in the JSON code. To set the cookie, we are setting the content type in this case. We want to define that the response from that action is interpreted as HTML. We define the status code, and there is a third element that we see here that wasn't in the first action, which is the body element, and we are returning some HTML as part of that. We can go further. Third example for sending an image. In this case, we are generating a PNG file from the OpenWhisk action. So there is a base64 encoded string that we can have within the action. It can come from where we want to. We are returning a header again that specifies the content type in this case as PNG, status code 200, and the body is the base64 encoded picture that we have defined in the variable above. So full flexibility in terms of the HTTP traffic. Again, we allow those two modes, either full control or you have plain JSON available. If you want to have access if you want to have access to the parameters coming into the HTTP request, that is possible as well. We can see an example here. There is a very primitive OpenWhisk action that gets a parameter, which is always the default. But when it's enabled as a web action, there are some well-defined parameters that come as part of that parameters object. You can see it at the bottom here. There is an OpenWhisk method, OpenWhisk headers, and OpenWhisk path element included, which gives you full access to what were the headers of the request that came in, what was the method, and what was the query listing path. So switching gears, besides some OpenWhisk native changes that we've made, we also worked with the Kong team to enable Kong as an alternative API gateway for people who want to use that because they have it already in use in other domains, or because they prefer the functionality that it provides to them. How does that work? There is on the Kong website a plugin section available. There is a plugin now for OpenWhisk, and you have to download that. The native way to interact with the Kong gateway is via HTTP request, so you can see that here in curl commands. The first curl command creates a new API in Kong. Kong is still running here on localhost. Once it's created, you can specify an OpenWhisk action to be mapped against that API. So what you can see here in this second step, there's a config.action parameter which has the value hello. This is the name of the action that you want to have exposed via the API in Kong. And once that is done, it's available as an API. And you can hit it with a curl command, and you can see, again, the parameters coming back. Next integration, Jason mentioned it also this morning, integration with PubNub. PubNub is a very distributed network for streaming applications. They have a concept called blocks. And a block in PubNub is something you can, I would say it falls into the fast domain, but a block is a piece of logic that only runs for a very, very short and limited amount of time, and it only gets limited memory. But it's very useful to have it because it allows you to, very close to the device, execute that logic and decide what to do with the data that's coming from a device or from an endpoint. And what we did is we worked with the PubNub team to enable them, so they build a block. You can find it also on the PubNub webpage now. And that you can use that block that you hook into the PubNub network. And if you want to, you can make that block call OpenWhisk as the backend. So what are potential scenarios that are relevant here? Just to give you some examples or inspiration. Vehicle dispatching. If you have lots of vehicles driving around, they are sending data all the time. Not all of the data might be relevant for the backend. But for the data you want to have sent to the backend, you can have that block send the data to the backend, and then it can do apply some more compute-intensive business logic or machine learning algorithms to navigate those vehicles elsewhere. Again, here's a split between the block as custom logic on the edge side, and for more compute-intensive, less latency-sensitive stuff, because PubNub is very close to the device, you would be using OpenWhisk here as the backend. Disaster alerts is the other way around. PubNub has connections to all the devices out there. OpenWhisk detects disaster information because it's interacting with the weather backend. Once it detects that information, it sends it to the block, and it notifies the devices. Another example is social chat apps, where people are chatting all the time. All of the data is being handled and routed via PubNub. For some messages, you might want to decide in your blog on PubNub that this should be handled in a more intensive way, it should be analyzed. You can pass it on to OpenWhisk, and it could be interacting with Watson to process the data further and do some analysis on top of it. How does that work in detail? You go to pubnub.com/OpenWhisk, you get the block there, you download it, and once you configured it, there would be, for example, a JSON coming in from your end device to that block, and it would be, for this example is very primitive, it gives you a parameter for the publish time, so when this message was published. The block, which we don't see here, hands over that information over to OpenWhisk. OpenWhisk would be doing some computation. Here it's very primitive. Usually it would be more compute intensive and long during. Here we are just calculating the time it took to the round trip. and then it returns the round-trip data back to the device. In this case, it would be 15 milliseconds. So these are new technologies, new integrations, new partnerships that we've been driving in the API space. I'd hand over to Andreas now, who will be taking you through the mobile backend scenarios and all the other categories of scenarios that we have been working on as well.
Thanks a lot, Michael. Good afternoon. So at this point in time, let's have a closer look at scenarios we consider OpenWhisk to be a good fit for, and as well as some scenarios our customers have already implemented. And as Michael has just said, let's start with having a look at mobile development. So mobile applications often, of course, need access to server-side logic as well. So very often you want to outsource compute-intensive tasks to a scalable cloud platform. But mobile developers are usually experts in mobile development, so rather than in experts in server-side logic development. OpenWhisk makes it very easy for them to focus really on developing mobile applications while at the same time getting access to server-side logic that maybe even others have written. And this server-side logic is then often implemented as an OpenWhisk action being exposed via the new API gateway functionality that Michael and Jason have explained earlier. Of course, since we also support implementing actions in languages like Swift, we even make it easy for the mobile developers themselves to implement server-side logic, and we even ease the consumption of server-side logic from within the mobile application by providing SDKs like our iOS SDK. So one customer using OpenWhisk in such a mobile context are the weather gods. The weather gods have developed a mobile weather application displaying different gods, and each single god is representing a certain element like water, fire, ice. And then depending on the weather situation, like rainy, snowy, things like these, they are displaying differently animated gods. In addition, they provide their users with a very smart weather condition notification mechanism. So this is what they do from a business case. So from a technical perspective, they are continuously checking weather conditions to inform the users about these depending on what they are interested in. So looking at this from an architectural point of view, so every 3 minutes they are calling an action which queries a subset of all of their users from a cloud and database. Then, for each single user, they determine the locations and the weather conditions they are interested in. After that, they call another action, which is the weather checker, and this connects against the weather company's weather service to get information about location-specific weather data. And then for each single user, this weather model is being checked by running so-called scanners, which are, again, OpenWhisk actions. So if a user is only interested in whether it's going to snow in New York or whether it's going to be windy in Austin, only these 2 scanners would be invoked in the form of OpenWhisk actions for this particular user. And as soon as one of these scanners finds something being of interest for this particular user, depending on what he has configured, a trigger would be created dynamically, which would guarantee that the action is supposed to be executed in the future to inform that user about what has been found by sending a push notification. This customer could implement all this logic here with server-side Swift. Another interesting scenario, which Jason already touched on during the keynote earlier today, is data processing. That's also of high interest in the context of serverless computing. So here, normally, data is being taken, is being stored in a database, like, for example, IBM Cloud, and then that causes a trigger to be fired, an action to be invoked, and the action is then usually operating on the data that has been stored in that database. Very often this data is multimedia data, like for example image data, video data, or audio data, and then the action is being responsible for doing things like audio normalization, generating thumbnails, rotating these images, doing things like these, or maybe video transcoding. One customer, and Jason mentioned it already this morning, we will now dive a little bit deeper into the architecture. One customer acting in this field and using OpenWhisk in such a data processing context is SiteSpirit. SiteSpirit has developed a solution for the travel industry where their clients need quick access to the right set of images, which might be images of a certain size, to create compelling campaigns. So this is why SiteSpirit has developed MediaSpirit, which is a cloud-hosted media library fulfilling exactly this need. So from a technical point of view, what they do is they are transforming images that have been uploaded by the client, and then they are providing their clients with quick access to all these transformed variants of the original image. So looking at this from an architectural point of view, the client just takes a picture, he uploads the picture, this is step number 1, to the object storage. This causes an action to be triggered, which then copies the picture to a Cloud-in database, which again lets the Cloud-in database emit an event, which again lets an action to be triggered, and then a couple of actions are being executed that all do different things, different image manipulations, for example, cropping. And then the finally transformed image, which might be a cropped version of the original one, is copied back to another bucket in the object storage to provide the customer with quick access to this manipulated one. The main point that I've not mentioned here, the main point is by going the serverless approach, this customer here was able to run everything 10 times faster and at 90% less cost, which is a very strong message in my opinion. Another customer, which is a Spanish bank that Jason already mentioned as well this morning, and we will have once again a deeper look at the architecture, is Santander, a Spanish bank. So what they do is they have developed a solution to bulk process bank checks using OCR technology to replace manual processing and to avoid human errors that might occur otherwise if you don't automate this. And also, same story as before, by going for a serverless approach, they could lower the cost dramatically. So they can now process all paper checks that have to be processed in one single year with less than $2 of cost. At the last conference, someone asked us, so how much did you need to pay before? And the answer was, we don't exactly know, but it was much, much more than $2. So very impressive story as well. So from a technical perspective, they are doing this bulk processing of bank checks, and they came up with a solution which allowed them to save a lot of compute power that they needed before to be able to handle high workloads that especially occurred on paydays. This is the point the problem that they try to solve. So from an architectural point of view, and I just go here stepwise from the left to the right, following the points 1, 2, 3, 4, the bank check is being scanned, so we have an image. The image is being uploaded to object storage, which causes an action to be triggered. This action is then generating resized versions of this image, and some of these images are copied to the archive Cloud-in database. These are smaller versions of the image, which they need for thumbnails, which then represent in user interfaces the end user is using. And another version of the image is stored in the audit database. Once the image ends up in the audit database, once again, a trigger is fired, here the change trigger, and this causes an action to be invoked. So it's the same pattern again. And then the passing of the check begins by calling a Docker action, which contains an OCR library, making the OCR possible. The data that has then been passed is being once again stored in another database, once again a Cloud-in database called the passed database. And once that information is available, another trigger is being kicked off, another action is being called, and this action is then responsible for doing the actual deposit and sending a mail to all stakeholders, including the customer, by sending a mail via SendGrid. Cognitive scenarios, which are a kind of special form of the data processing scenarios that I've mentioned before, are also of high interest in the field of serverless computing. So once again, you have data, you store it in a database that causes a trigger to be emitted, that causes an action to be invoked. In cognitive scenarios, the actions are usually calling cognitive services, like, for example, our Watson services, to do things like detecting persons or objects that appear in images. One solution that we have developed recently is called Skylink, and I like that one very much. So here in that case, a drone is continuously taking pictures while flying around. And then each single picture is uploaded to a Cloud database. The Cloud database is then emitting an event, which causes an action to be kicked off. And this action is then sending information about information about this picture to a cognitive service, to Watson, so that Watson can analyze that image. So this allows insurance companies to train Watson to detect damages on roofs that might have been caused by hail. This means insurance companies can assess the damage that has been caused fully automatically without the need to send people into the field. It's a really interesting use case that can probably apply to many other very similar use cases as well. The same way we need to be able to process data at rest, so data being stored persistently in databases, we also need to process, of course, data being in motion, so like streaming data. For that purpose, we have made two things available. For our open source project that Michael has mentioned at the beginning, we have made available a native Kafka integration. And for our commercial offering running on Plumix, we have made available an integration with Message Hub, which is actually a Plumix managed Kafka. So once again, as data arrives, a trigger is being kicked off, an action is being fired, and then you can process that data by executing custom application logic. We meanwhile also support processing binary data, which is especially of importance if you are in an IoT context, because many IoT devices do not send textual data, they send binary data. So this is why this is especially important. The availability of this Message Hub integration also eases integration with other SaaS offerings. So in this context, IBM App Connect allows especially business users to model flows, to fetch data from one source system, transform the data, and push it to another target system. So what you can, for example, do is you can fetch information about new contacts that have just been created in Salesforce and then push that information to Message Hub. And then, based on what I just taught you before, you can execute an OpenWhisk action as soon as the data arrives at the Message Hub. And this OpenWhisk action can then operate on this data just by executing, once again, custom application logic written in any language that we support. Processing IoT data is, of course, another interesting scenario that we are currently looking at. But the important point here is, of course, you do not want to execute one single OpenWhisk action for each single data point that has been sensed, because that would cause unnecessary cost. So what is usually being done is that the data that has been sensed coming from a device is sent through our Watson IoT platform, and there we have something that is called real-time insights, which allows you to model rules. Rules like, if these two temperature sensors report a temperature higher than this and that, then please evaluate to true. And if the rule evaluates to true, you can invoke, once again, an OpenWhisk action just by calling it via a webhook. And then you can process based on what has been reported by executing custom application logic. So if the temperature sensor has reported a very high temperature, you might want to set off an alarm, call the fire department, or activate a sprinkler system, whatever you want to do. One customer who is using OpenWhisk in such an IoT context is AbiliSense. AbiliSense is a company providing solutions for smart home security, and they are able to translate audio and other sensor data into alerts. What they want to do is they want to help people with hearing disabilities to get informed about critical situations without the need to rely to other persons. So from a technical point of view, or from an architectural point of view, this here is how it works. I won't go through all the typical flows here, possible flows here. They have developed an appliance, which you see here where the number 1 is. And this appliance is continuously recording ambient noise and also recording information coming from additional sensors. The sound file that has been recorded is then being uploaded to object storage. Once available in object storage, an action is being executed, and this action contains an algorithm they have implemented which allows them to detect patterns in this audio file. So for example, they learn based on looking at this audio file if a window has broken in the house, which might mean that someone has broken into your house. If this is the case, they activate the next action here at number 4, and this is then responsible for informing the user that something is going wrong. For example, by letting this appliance that they have developed emitting light signals, I mean the people they can't hear, or by sending push notifications to their mobile device. The appliance is also able to detect other things by using other sensors. This sensor data is then going a similar flow, but is going through the Watson IoT platform and the real-time insights technology that I've mentioned before, but the final result is the same. If some information coming from these sensors indicate that there is a problem, they are being informed by a push notification again. The cool thing is they went serverless, and that allowed them to process data coming from thousands of these appliances, altogether resulting in 5 million action invocations per month for less than $15, which is, in my opinion, a very impressive number. We also have, in the context of IoT, an integration with Node-RED. So Node-RED is a flow modeling tool being used a lot in the field of IoT. And our integration allows you to invoke an OpenWhisk action to, for example, outsource, once again, compute-intensive tasks to our platform at some point in this control flow. So this is something you can just try out, download Node-RED, download our integration for Node-RED, and you can, at any point in this control flow, open an OpenWhisk action and execute custom application logic in a very scalable fashion. This is something we have already seen when we have looked at what the weather company is doing. So all of our actions can also be executed in a periodic fashion. So here we support a cron-alike syntax. And then last but not least, because currently very, very common, a lot of people like doing this, and this is also what we have done during our workshop, which we carried out 2 days ago here as part of the conference, and that workshop will be made available soon public, so if you're interested, you can then have a look and can do it on your own. People like using a technology like OpenWhisk to implement chatbots. So for example, if we think of Slack, which is only one sample, if someone is entering a message into Slack, then an OpenWhisk action can be called by calling it by its API endpoint. Then the OpenWhisk action can process this message that has been handed over, and can send back the response by calling a well-defined API endpoint the chat application itself provides. Yeah, of course, there are a lot of other scenarios that our customers are looking at. This is just a sub-selection of the companies we are currently working with. And what you might see is there are big names there, like Santander. Jason pointed it out this morning as well. But there are also a couple of startups that we are working with that are doing really cool things. So Jason, for example, explained what Articulo is doing. Maybe some of you have been attending the Green Queue session yesterday. They are working in the field of Internet of Garbage, so they are equipping their trucks with sensors, and then all the sensor data leads to actions being invoked that need to be analyzed. And we have a couple of partners that we are working with, for example, Adobe, which are helping us a lot. See some people from the Adobe field here in our with respect to our open source efforts. Yeah, with this being said, wow, 0. Just in time, I'm done. Thanks a lot for having listened. And if you have additional questions, feel free to step by at our booth. We are here for the next couple of hours in the main tent. That's it from me. Thanks a lot.
You got it.